In this video, I'm going to tell you about all about bit manipulation. Now, basically, what is bit manipulation? If we are going to write here, bit manipulation, so what is bit manipulation? So, in basic language, when we have to deal with the bits, now bits are what is the representation of a particular number if we write here? Now, suppose if I write 1, then 1 in binary can be represented by 0, 1. 0 in binary, we all know, is represented by 0, 0. So basically, bit manipulation is all about the handling of numbers in the binary form. Like whatever you have to do in the binary form, and you have to do it using the bitwise operators. Now these are bits, these are bits, these are bits. Now when we are writing in binary, we all know that binary can be represented by two numbers, that is 0 and 1. So all the numbers have to be represented by this. So just like that, if I try to write the number 2, so 2 will be what? 2 will become 1, 0. 3 will become 1, 1. Now, if you have to write number more than 3, then that 3, number 4, for example, it can't be expressed in binary form in 2-bit system. You have to take at you have to take 3 bits, at least 3 bits. The reason why I'm saying at least, because the rest of the bits, like if you are representing an integer, so integer variable can store 32 bits. So if you are expressing a particular number in 3-bit form, like if you will be writing 4, you can't write something in 2-bit form. So you have to use 0 simply, and simply you have to write like in 3-bit form. So what is exactly 4? When you are expressing the rest of the numbers above 4, that is 0, 1, 2, and 3, you will find that 4 is represented like 1, 0, 0. Now you see the number of bits here are 3. So just like that, integer and the rest of the 29 bits, since integer can take 32 bits, the maximum range of an integer. So the rest of the 29 bits can be filled with 0. So just like that. Now, if we have to do binary operations, then like the mathematical operations that come in binary, more importantly, we deal with addition and subtraction. We have to deal with addition, and the other operation that we have to deal with is subtraction. Now, the basic rule for any binary addition is that 1 plus 0 is equal to 1. 1 plus 1 is equal to 0. And 1 carry 0 plus 0 is equal to 0. And like the another one is 1 plus 1 plus 1. When you are adding three ones, then the result will be 1 and 1 carry. So like these are the basic rules of binary addition, and you can add two binary numbers based on these. Like this you would all be already knowing here. So addition is not the thing that should be talked about. The next is subtraction. Like as I told you before, like two operations that in binary are mostly needed, that is addition and subtraction. So now we come to the thing of subtraction. Now subtraction, how we do subtraction? Suppose if we have to subtract a, now here a and b both are expressed in binary. I'm talking in a very generalized way. So here A and B both are expressed in binary. So like A minus B you have to do. Now, we don't actually in subtraction binary, there is nothing like subtraction here. How we actually subtract B from A. Like this A minus B, what means? It means that we are subtracting B from in simple words. So what we do? We take this B, we firstly use the not operator, that is negation, and then we add 1 to it. And then whatever result that we get here, suppose X we are getting. So we simply do finally A plus, and whatever result comes Y in normal format, this is equal to A minus B. Now when we do this, what we are doing this is what? Firstly, we are applying not operator to B and then we are adding 1 to it. This is known as 2's complement. I hope it's clear. So this is binary subtraction. Now, A and B, as I told you before, always keep in mind that these two are the numbers that are in binary. So if two decimal numbers are given, your first duty is to express them in binary. Now, just like that, if I tell you about a little bit of knowledge prerequisite that will be required here is not very big. Like if you have to convert a decimal number, suppose 63, then how do you do? You take this, then you divide it. So this will go by how many times? This will simply go like this, and here you will get 1, and then you do like this and this on, and you write it like this, like from below to 1. This becomes your MSB, and the last one becomes your LSB. Now, MSB stands for most significant bit, and this stands for least. Like this stands for actually maximum significant bit, and this stands for least significant bit that we notice. So coming and now supposedly if a binary number is given and you have to like convert it to decimal. Supposedly number is given 1011. So how will you do that? You must be knowing this, that here are how many indexes. Binary indexes, you always know that they are taken from right to left. Like if we write a string or kind of thing that we index it, we start indexing from this side. We start indexing from left to right. The reason is simple. This what we do. The reason is simple that. So this will come 1, this will 2, and this will be 3. So these are the indexes of the binary. So when you convert to decimal form, you simply take 2 to the power 3 into 1 plus 2 to the power into 0 and plus 2 to the power 1 into 1, and the last will be 0, and 2 to the power 0 into, so mm, here it should come 1. So what will the value of this be? If I write it here, this will come as 8. This will result into 0, obviously. This will result into 2. This will result into 1. So 8 plus 2 plus 1, that is equal to 11. So this is the method that you normally require to convert a binary number to a decimal number. So we can write here that this represents 11 in decimal, and this was in binary. So coming to the fact, so this was the method to actually convert a number from binary to decimal. Now, since I told you that in bit manipulation, we actually deal with the modification or any kind of operation on number that is in binary form, and that is using what? That is using like you call bitwise operators. So these operators always work on binary operands, remember. These operators always work on binary operands. Now, even if you just try to give them two integer values that are not expressed in the binary, they will always assume it to be binary numbers and they will operate it internally. Like you don't specifically, first you have to like take the number from the user or from a programmer, whatever you call, and then you have to convert it in binary and then you have to pass it. You don't have to do like that. You have to simply just take the number in the integer form. Suppose I enter n equal to 20 and n equal to 15. And then I just using the bitwise AND, I can simply do the operation. So what is bitwise AND do? This is bitwise AND, this is bitwise OR, this is bitwise exclusive OR, which we normally call as OR. This is bitwise left shift, and this is bitwise right shift. So if you have confusion, you just have to see the direction in which they are pointing. So this is left shift. I'm writing here also. LS stands for left shift. This RS stands for right shift. This is OR. This is AND. And this is XOR or exclusive OR. I hope it's clear. So these are the operators that we normally use. And like coming to each of the explanation of each operator. So the bitwise AND, if we write about the bitwise and does what? Suppose if we have two operands A, B, and we apply AND to both of them, like this, this. So what does AND do? So AND will only result in one when both of the numbers, yeah, like the both of the bits are one. Like if I write here 0, 0, 0, 1, 1, 0, and the last is 1, 1. So the property of AND, this is a very powerful property that if and only if both the bits, if and only if both the bits are 1, then your AND will result into 1, else it will result in 0, 0. So this is the property of AND. So I repeat it again. If both the bits are 1, then only AND will result into 1, else it will result into 0. So next is your bitwise OR. So bitwise OR, if I take, if I take, so the bitwise OR does what? If both the bits are 0, then only it will return 0, otherwise it will return 1. So what do I mean by this? Is that if I write 0, 0, 0, 1, 1, 0, and the last is 1, 1. To make it not that confusing, so now what will be the output if I apply bitwise OR? So 0, 0 results into 0 because of or only results in 0 when both the bits are 0 and rest are 1. So this was bitwise OR. Next comes bitwise exclusive OR, that is XOR. So if this is A, this is B, and this is A, XOR B. Now for XOR, a lot of times people will speak it in different ways. But if I just tell you how do exactly it works, like what type of definition that I use about XOR. That is simply if the number of ones, like here are two variables A and B. So if the number of ones odd, like there are two variables A and B. So the number of combinations that you will take will be only for two variables. So in the case in the two variable system, what will happen like that? If the number of ones are odd, then your XOR will return one. Otherwise, it will return zero. It will become more clear when I will just explain you this. So it is zero, 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 one, one, zero, and the last is one, one. Okay, is that clear? So I will write it like one, one. Now in the first, you will see that there are no ones. So zero. And I said you the number of ones are odd. So zero is an obviously an even number since it can be divided by two. So yeah. So in this case, if number of ones are not odd, since in the first case the number of ones are zero, so the output will be zero. XOR will only return one if in the two-bit system or in any of the given variable system, the number of ones, I repeat, the number of ones are odd. So in the next case, this will return one, this will return one, and the last one, the number of ones are two, which is surely an even number. So this will return zero. So this was all about bitwise XOR. Next comes your like bitwise right shift. This is bitwise right shift. So if a number is there and like I tell you, bitwise right shift 101, and I tell you like A right shift 2. So what is the output of this? Like a right shift means if you write A right shift 2, then each particular index will get right shifted by 2. What I mean by this, let me tell you. Then now finally this 1 will come two places. So 1. Then this the 0 will come like this one will come two places and next are like 0, 1, 0, 0. This will be the way. So this is simple. This will become the value of A. Now, how did it happen actually? So let me tell you, like 101 was there initially in variable A, then you wanted A right shift 2. What you wanted? A right shift 2. So obviously this, this, this. So if you want to shift the whole number right, so what you will do? You will simply do the first number, take the first number, and you will do it like shifting. So you will shift it by two. So it will come two places. So this is the place, and then the rest are here are a lot of zeros. So rest of zeros come. You can write indefinite zeros, but this is the output of bitwise right shift. I hope it's clear. If there is still doubt, I will repeat it again. A is equal to 101 is a number. You apply bitwise right shift by 2. So the first number will come. Indexing is done from 0 to 2, from right to left. But if you take the first number of this bit, then what it is? It is 1. 101, I believe. So the first number is 1. So 1 will get shifted by 2. So it will come at the index of the other one that is on the this index. And next are here a lot of zeros. So out of those zeros, you can write two or you can write the remaining ones. But that doesn't make any sense. So this is okay. Now comes bitwise left shift. So I again take the example bitwise A is equal to 101. And if I apply bitwise left shift 2, so initially, just like the previous time, I have again taken A is equal to 101 and I have applied this time a left shift 2. So what it will be? So now this will come here and it will become like this particular. This will come this side and A will become 0, 0, 1. If I just tell you, so initially, like I took the number, what I took? I took the number 101. I took it. Now, we know that if a number is placed like this, then there will be, we can shift this side. Now we have to shift where? We have to shift to our left. Like left shift operator simply means that we have to shift it to our left. So simply what we will be doing here is that we will be shifting this to our left. Suppose the number is like that. So this one will be shifted this side to left. This will come to left and this will also come to left. So this will be the representation. If A is equal to 101, so this is the representation of in the binary format. Now, what is this? I tell you, we were applying the left shift operator, and the number was A is equal to 101, and the instruction or the statement was A left shift 2. So, what does that mean? That each and every bit given in the number A, given in the number A, each and every bit, since we have to it left shifted by 2, so each and every bit will come shift two places to left by 2. So, like here will be zeros and all. So, like there will be a lot of zeros after this number. We all know that. What we can place, that we can place number of zeros after this number. So these ones will be shifted to their two places to left. The number 101 will be shifted to its left by 2. So this one can will this side. This one will come. So this 0 will come to its left by 2 and this 1 will come to its left by 2. And what we will be doing is simply that we will simply do this particular number we will be getting after applying the left shift operator. So now one important concept. If we left shift a particular number by I, the number reduces by the factor I. Suppose if I do B left shift I, then this will be B by I, B by I, this means. And if I do the right shift simply, then the number is simply, sorry, I told you, vice versa case. So the number gets multiplied by the factor. The number gets multiplied by the factor I. If left shift operator is there, you can see in this question, it became 10100, and in this case, it became 100. So the number was reduced, and here the number was simply like the number was simply increased by the factor of 2. So this is a basic property, and this property in maximum cases is valid for I is equal to 2, 4. Like, let me tell you one thing. The proper implementation of this property, I'm just telling you. What we have written here for the B left shift I and B right shift I is equal to 1. This is 1, comma, 2. Like if you do B left shift 1, then it is simply B into 2. Let me tell you. In the next slide, B left shift 1 is B into 2 and B right shift 1 is B by 2. I hope it's clear. And B left shift 2 is B into 4. B right shift 2 is equal to B by 4. I hope that makes sense. This is not 9. This is not 9. This is 4. And to correct you, therefore, I've written here this is for I is equal to 1 and 2. This is 1 and 2. Now, now it comes to the fact that if we have to check for odd and even, if you have to check for a number that it is odd or even, suppose a number B is there, and if it is AND with 1, what if it has been and in the sense the what we have to do here, and in the sense like if we apply the bitwise AND on B and 1, so this will specifically deal in binary. So if this comes 1, then it is odd, and if it is comes something 0, then it is even. What we do, we take a number B using a bitwise AND, we simply apply another operand that is 1, and we do the AND, and what we get, if we get 1, then the number is odd, else if we get 0, then the number is even. Now, how we do the swapping of two numbers A and B? So for this, we use X or A is equal to 5 or and B is equal to 7. What we have to simply do, firstly, we have to take A and we have to store the XOR of A and B in A. Then we have to take the variable B. Those are the two numbers only. A and B are the two numbers that were entered. And we have to again store the XOR of A and B. And finally, we have to update the variable A in the XOR of A and B. This is the particular process of swapping the two numbers. So what we have to do, firstly, we have to update the value of A through A XOR B, and then we have to update the value of B through A XOR B again, and finally we have to again update the value of A using A XOR B, and simply we have to print A and B. So our next topic here is like what is bit masking? What is bit masking? Now what is bit masking exactly? In proper thing, masking is simply here means if you have to obtain a particular result, like if we have been given a number 1, 0, 0, 1, or simply 1, or suppose this is also 0 here, supposedly this is also 0 here. So now, if we are supposed to ask, suppose if we have been asked that in this particular number, Where is the one located? This one is known as set bit. In any number in the binary form, the number of ones they are commonly called or they are called as set bit. So if we have been asked that find the set bit, like find the set bit. So what we have to do? We have to simply take a mask. Mask of what? If we write here simply 0, 1. Supposedly, if we just take the 1, the number 1, so 1 in binary can be written by 0, 1. And if we just simply, or if we have to find this particular bit, suppose if we have been asked, find the what, 0, 1, 2, 3. If we have been asked, find the third bit. So what we have to do? We have to shift this number. We have to do what? We have to shift this number by the required bit. So what we will do? Now number has to come to its left side. So this we have to do. And like which is the property which will simply give rest of the results 0 and this particular result as 1. That is simply AND. So this particular number on doing AND with the given binary representation will give you the set bit simply. Now, if you do, like if you take the given number, like if you take the given number 1, 0, 0, 0, and if you, after doing, if you apply the OR, bitwise OR with mask, this is the ith. Like if you have to set the ith, you this time you don't have to identify the ith bit, you have to set the ith bit. Like it is given 0 and you have to set it to 1. Supposedly, you have to set it to 1 and at this ith index of the given number, this particular number is 0. Suppose you have to set this number, this bit as 1. So what you have to do, you have to simply take this number and you have to simply you have to do what? You have to simply using the OR operator, bitwise OR operator, you have to get the result and you will get to know that you have set this bit to 1. So this is process of setting the bit. Now next comes clearing the bit. Clearing the bit means what? If you have to do the reverse process. So if you have to do the reverse process, you will do what? You will simply, if you have to clear the set bit, then you have to take the given number. Suppose this bit was set to 1 and you have to clear it. You have to clear it like you have to make it 0. So you have to do what? You have to take this and you have to simply using the negation. Don't forget. This is your mask. I will write it more clearly. This is your this is your mask. If you take this particular thing and you store it in a variable, like this was a particular number that was entered, this can be any number, and using the bitwise AND operator, mask is your this is your mask. So this is your mask, and like this particular is the process of setting the bit, like it was 0 and you have to set it to 1. This process was for like if you find the particular bit, like which is the if you find the ith set bit. So how you will do? If you have to find the ith set bit, what it is, so you will simply do the AND. You have to do what? If you have to find that at particular index given, what is the bit? Then you have to do this. If you have to set a particular bit, you have to set the bit. Setting the bit means that you have to make that particular bit from 0 to 1. Then you will take the mask 1 left shift I, left shift I, and you have to take the OR operator, bitwise OR operator, you will get the result. Now, finally, if you have to clear that particular bit, if you have to, suppose an index is given, you have to clear it. Then you will do what? You will simply take the given number that was given, and you will take the mask. Now, what will be the mask here? You will take one is normal number. You have to shift it by the particular index that is given that you have to clear. Like suppose if you are saying that you have to clear fourth bit, then what you will do? You will simply take one left shift fourth. You will take what? One left shift fourth. You will the answer will be coming after one left shift fourth. You will take the negation of it. Negation means what? Negation is simply ones will be zero, zeros will be one. And then using the bitwise AND to the number that was supposed to be, like in which the bit that particular bit has to be clear, you will get the answer. So I hope it's clear. This was all about bit manipulation. So thanks for watching and stay tuned for more content. And don't forget to share and subscribe. Thank you. Thanks for watching.